Hello, and welcome to Iron Riddle, a show where we do many different things. Like, for example, traditionally for the past few episodes, we were fighting with Twitch not actually working, but now I see that finally it fixed itself, so it wasn't any problem on my part. Okay, apart from solving or not solving our technical issues, what we do usually is trying to understand how Target works, and usually it is like, mostly a code review of existing code. But sometimes we notice like, a little small thing which is off and figure out, okay, actually, let's like go and fix it. And that might turn out to be a giant rabbit hole, which is exactly what happened when we started studying TargetBeetle's query engine, when we realized that, hey, actually there is something going off, and long story short, we are trying to simplify our K-way merge implementation, which is using loser string, which is kind of like not like, like grand scheme refactoring like we did with compaction almost a year ago, I think, at this point. But rather like, a more tactical, narrow, let's just clean the code up, which is still freaking complicated. So what we've ended at last time was actually refactoring our fast tests to write a minimal test to find like the smallest possible bug. And that was successful. I actually merged that work last week. So today we'll hopefully actually use that to debug our code. So let's just go into this, right? Okay. I'm so glad that I no longer have to apologize for Twitch not working. Thanks to Twitch for fixing your stuff. Okay, so let's see, where are we at? We have smoke test. This is what we've been writing last time. And this is already in the main branch. So I will use my standard way of, let me flip this also to dark mode. I will use my standard way of, merging changes, which is just doing it all again. Is it? Yeah, okay, it is merged. So Let's see. This is the test which should show us the minimal bug. Let's check that this still fails and then continue with debugging this stuff. Okay, perfect. This fails. Now, actually, okay, let me maybe short circuit this because, yeah, we actually already have the smoke test here from last time. So I will immediately start with the smoke test rather. Okay, we merge smoke. Okay, let's see if this thing fails. Okay, it doesn't fail. It doesn't fail. Okay, then okay. Just to be paranoid, maybe I mistyped the name somewhere. No, okay, it works. So no, we'll have to do this the hard way. So let's do the exhaust again here, and before we do this, we need to say direction, and for streams stream any string. Okay. So let's see what fails now. Oh dear, because okay, this works because this isn't actually this isn't actually the code I want to test. Okay, so let me do this. Yeah, I kind of like accidentally reverted not only my changes to the tests, but also my changes to the code itself, which is not something I want to do. Okay, yeah, so now this smoke test should fail, hopefully. Okay, yeah, task failed successfully. Okay, let's see what happens here. Okay, let's just no. Distant. Let's just add some good old debug prints there. How quickly? Okay, so we fail once we and well, equals key and value equals value. Okay, so what do we see here? What format with an optional too bad. And by the way, so this is why I like love this interface, because like there is like a reference phrase here. So like just you cannot like show error message because it's not clear from the compiler where exactly error message happens. And in this interface where I could just go to definition to any of those lines, this makes it like very easy for me to say that hey, we need to have a question mark there. I always find that it is worthwhile to make your output more compact. So let's see what actually happens. So we pop and then we pop key number 0. That is okay. And then we pop this value. Then we kind of like insert null, saying, hey, this string has ended, and then we hit this. Okay, now let's try to figure out what actually should be doing there. Yeah, so this is probably not good because we are expecting to have one more contestant after we pop 0. Okay. It's been ages since I was like debugging like this algorithmic code, so it's a good experience. So I think what happens here is that we incorrectly determine the number of contestants. Because well, no, okay, no, it is no, the contestants count is correct because it was 1 and then we left 2. So okay, something seriously fishy is going on here. Okay, this is annoying. Let's see, pop. Winner before. Let's see, cell 3. Winner. ID. Winner after. Okay, yeah, so it's kind of like looks reasonable. Winner before 2, winner after 2, winner before 2, and then we crash. Okay. Really don't understand what should be happening here. Okay, let's see. I want to print, I think, 3 ID and ID. What happens here? Could it be the case with our like empty? Well, let's see. So I would expect the contested count to be equal to 2 here. Okay, so this is correct. And that all is also correct. So yeah. Okay, I am positively stumped here. Okay, let's see just how we've set it on nodes which always works. Okay, it doesn't make sense to me at all. So okay, let's actually manually reproduce what is happening here. So we are going to stream. No, I don't want to do this. So yeah, basically, my problem here is that I'm refactoring Stubby's code, so I don't have a visceral understanding of the code. And I made a bug when refactoring it. And the problem is, and what makes this challenging to me, is that I want to kind of simultaneously gain this visceral understanding of the code, but also maybe not gaining it and just find some obvious bug, which I missed before. And that is not easy. Okay, so what would we do here? So So this actually should be super. Okay, well, let's do this. Does it compile? Okay, so somehow this, okay, so maybe I'm getting somewhere. So let me drop all debug prints first. So this thing here really breaks the stuff, right? But we know that when we init that contestant count is the same, right? So it should print 2. It prints 2. And this way it also should print 2. and it prints 2. So let's actually maybe just print contestants count and see the difference between the two. Okay, Zik isn't being helpful here. I really don't care about seeing these. So K1, AD0, A0, AD2. Okay, so this is what we expect, really. And this, wait, actually, let me, let me actually try to solve distance. I think we did have a better okay, yeah. So this is better. So we could actually do even this. Distance. So this is kind of like meta problem. You see, like I tried printf debugging, and the problem there was that like the printer was too verbose for me to figure out what's going on. But and then I figured out, okay, actually I need to like solve this problem before I actually debug the thing, because next time it will save me effort debugging. And then I realized, yeah, actually I've already solved this. There is the standard X debug helper, which shows me a nice and clean result. Okay, so this is what I get with 3, right? This is what causes me to crash. And if I comment this out, I get this. So the only difference is in IDs, but that seems fine, like really. So this crashes, and this passes. Okay, so why would ID matter? The Sentinel. Why would ID matter? Do we expect IDs to be dense anywhere? Yeah, okay. Oh, okay. Maybe. It's. So what kills me is that IDs are not dense in this scenario. So if this works, this doesn't. And I have no idea why that would be the problem. Because yeah, those should be equivalent. Okay, it's how long have you been seeing me like completely stupefied? I got this stupid bug, like it is like third episode. Well, sorry about that, but well, like sometimes programming is like that. Um, the inner ID. I feel like it's going to be like, you know, something like super stupid. Okay. Yeah, they are like virtually identical. ID. Okay. Let's do a differential debug. Compare the case where it works to the case where it doesn't. So this is a success key, and this is failure. And yeah, it starts the same. So like just different ID and then 0 and then null. And it is the second null which causes us to crash. Right? Right. Okay, so let's see why that could be the case. Okay, the key itself is not used to determine whether a node is a sentinel. This ensures that valid keys with the maximum value are not treated as sentinels. So, okay, maybe, okay. Let's see, like, I have another suspicion here. It's, maybe somehow the rest on the contestants array matters. But no, it's literally is the same. Okay. But okay, I sort of feel like I narrowed this down to something very specific, which doesn't make sense to me, rather than something very general. Okay, let's do more. Winner. Let's see what we are swapping. Okay. Okay, let's actually maybe do this. K-Winch-R, K-Winch-Bear. And then we could do this to speed up our iteration time. And then we do this. But I still want to see the output. Where's my output? Well, I don't have output because it is B, not 2. Okay, yeah, so this is the difference. So here we swap like that video. Okay, let's then do. Okay, I actually want to maybe do this. So winner opponent, AB. Winner opponent, AB. Okay, and now if we check to A, okay, so this I think is the difference, because winner and opponent here is Sentinel, and there I think the first opponent wasn't Sentinel, right? Yeah, so the first opponent was okay. So how do we get opponent ID? Yeah, opponent ID is 1 and opponent is like some nastiness. And here, opponent ID is 0. Okay, yeah, so okay, I see it. So we do Okay, so we do rely on IDs being dense here. I think. Okay, yeah. Okay. Yeah, guys. So sorry, guys, but I'm gonna sit here. I think now like token time finished. Now I need to think. So this was bug in my understanding. I was treating IDs as just opaque identifiers, but apparently IDs are actually meaningful. And I bet that if I look at the original code, it would be like pretty obvious that IDs are meaningful. Okay, so let's actually do this and see what the original code has to say. Okay, we merge. Okay. So when we originally were loading stuff, what did we do? We kind of like did the same thing, right? So we were just skipping IDs. Okay, I don't really. Oh, well, the good thing is that we can now copy paste this here and see how the original code works. Build test. We'll be fine if this crashes. It doesn't crash. Huh. Yeah, so maybe but okay. But still, let's see. So 20202. And if I comment this out, 000. So it kind of like feels like Tender Sentinel. And which assert fails here? Winner. so the winner ID. Okay, okay, let's see. Then the ID Sentinel. I want to see this thing. Kind of like looks suspicious. True, false. Okay, so let's maybe ID ID. Let's maybe just align debug printing between a working version and a parent version, just to see where exactly we are diverging. Okay, and let's get reads of all the debugs. Yeah, in Rust, I actually have a code action just for this, but not here. So, winner ID. Okay. And I want a here. I don't want any extra stuff here. So opponent ID 1, 2, 1, and like Sentinel 2. Okay, why does it? Oh, maybe it's not count. Maybe it's not stream ID. Not count. Doing ID. Count. Doing ID. So it's kind of like still feels very wrong to me. Countries, stream ID 2. Okay, so this I think where we will see the difference. Because there, not count is actually 2, right? Get count. Wait. Okay, I say that not count here is 1, but this one says that not count is 3. So nodes count definitely is incorrect. How do we set this? Nodes count equal to nodes count. And what is not counts? Is diff count minus 1 in this version, and here nodes count equal diff count. What doesn't make sense? Nodes count. Let's see initial nodes count. So 3, and here 1. Okay. So contestant count. And what is contestant count? So in our case is actually the number of non-zero nodes. Streams count. So IDs must be dense. So in other words, here, if we set okay. Okay, so well, at least we debugged this, I think. So let's see. Can we just say at ID max? Okay. ID max 16 equals 0. Constant ID. Case. Okay. Count max. Count plus 1. And then here I change this to string count, and then it should work. So consistent. Okay, let's say text. Okay, this is all very incorrect. we still okay. Okay. Let's see, where are we using this doing count as well? Let's count. Well, then this should I'm starting to hate real rulers, honestly. Okay, but okay, let's then compare. So we identified like one point of divergence, and that is that original code treated the total number of streams as a number of nodes in the tree, and my refactoring only looked at non-empty ones. So I hope that, hey, I kind of fixed the divergence and that would be it, but apparently that's not been the case. Yeah, so now we still get the divergence here. So the first line matches, but the second line doesn't. Which makes zero sense to me. Now, okay. I guess one thing we can confidently say is that I'm extremely bad at working with heavily algorithmic code on record, which I'm fine with. Okay, but why? So in this scenario, first we say we know this stream, and then this stream. Well, okay, I think nodes count prints we can get read all. They aren't really useful to us anymore. Okay, let's maybe do this to see whenever we exit this loop. Oh, Toby, how could you wrote that? how can I find this so possible to debug? So let's see. Like first is like our like initial iteration where we pop like same winner. So yeah, that makes sense. And then we say, okay, so now this one wins. Okay, that makes sense to me. This one doesn't make sense to me. Okay, let's just maybe let's just print. Let's maybe just print losers. Yeah, losers look rather different. Why would losers look rather different? So, contestant, competitor index. It feels like oh, okay. Maybe losers are different because contestants are different. See contestants. Wait. So we actually fully feel. Oh, okay, so we aren't filling them sequentially. Aha, ha 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 ha, and they must be sentinels. Okay. So this is the second big difference. So when we're calling it here, actually what we want. We actually want to say maybe use size. And then Okay. This now makes sense. But it's still fewer than not count. That's fun. So actually no. We pass contestants, but we also pass string count. Okay. But we also see where distance left 16 equals 0. Okay, do we ever materialize? Okay, no. Aha. So this one is kind of like, if doing is empty to start with. And then we say distance left plus equals 1. Distance left. Okay, so now hopefully it will just not compile. But well, completion errors we can always just fix. Well, okay, so now this we definitely need this string count. Yes. Okay, it works. Okay, it works. Okay, I realized that I probably should use debug macro more, because it also has this very nice property that you don't have to do this. You can just import it and then it is done. Okay, so nice. Okay, let's see. What was it called? Exostiga. Let's see if we are winner. Okay, yeah. I think we've done it. I think we've done it, guys. I think. Oh dear, like I hate programming. But I think this works. Well, I mean, we still have to run benchmarks and see if this is actually faster or not, but I kind of like this. Okay, so let's see. So we don't need this. Can we just do this? Okay, we merge. No, no, it still fails. Why it fails? It worked. Okay, let's do bigger run. And it will take time. New entrant. New. But fast still fails, right? Okay, so what if we do this? Okay, so it gets worse and worse. Because now we have tests which doesn't actually minimize. And this is daily one. But I like, yeah, it feels, I mean, if it wasn't on record, I would have given up, honestly. But it sort of feels that there is some merit here. Okay, it's funny how this really doesn't minimize at all. Okay, so let's maybe leave this one in the background. And check unit tests. Unit tests work. Plastics break. Like just how big of a slice do you need to break? You know, 10 is enough. 5. Maybe just 2. Okay, oh, that's good. Twenty. 15. 10. Good, let's do this. Okay, so just 10 is enough. 2, 3, 4, 5, 6, 7. Okay, so 7 streams are enough. Okay, so 6 streams are enough, right? Or maybe 5 streams will be enough as well. 4, 3, well, maybe just 2 of them. Well, it's kind of like really funny that we are not fighting with exhaust again. Doesn't really make sense to me. Well, let's do this in the release mode. Const C 64. find one that's it, and then we'll go from there. So this is our repro, which should be relatively small, I hope. Oh, no longer need this to be built in release. And let's see. Okay, so we do this once in ascending and once in descending. Let's see if it's ascending or descending. So it's only, huh? Okay, now oh, well, maybe this. If I comment out reset, then it works. Okay, so maybe there is something wrong in the reset. Go on here. Let's see, context, string count, direction, key popped. Ah, okay. So I think this is easy because I should actually preserve key popped. Because this is not really full reset. Okay. So this last one actually was pretty fast to debug. Okay, so now finally, now finally, I think we can, with some modicum of confidence, say that we achieved behavior preserving refactor, which is a code transformation which does absolutely nothing useful, doesn't change a behavior in any way, but at least it doesn't break the code. And it only took us like what, like 5 hours of live coding? Okay. Well, but at least we are there. Okay, so and then it kind of like explains why exhaustive test wasn't actually able to find this, and that is because the bug wasn't there. So actually, I should have took that signal as, hey, the bug is in the difference of coverage between fuzzing and stuff. And the coverage is exactly in the reset method. So kudos, Toby, for specifically adding fuzzing of the reset method. It saved my bacon. Okay. So now, well, we have the K-way merge benchmark. Do we have it? Because I'm like, yeah. uh, kind of like curious what we'll see here, because like, you know, if we also see that, hey, it's like now 10 times slower, that would be kind of like not a good outcome. But let's see. So is it reproducible? Yeah, it is. So 30 nanoseconds per element. Now let's see. What is the main range? It's like, you know, like 3 nanoseconds per element. And I was like, no. Takes a while to compile. I don't know, we are not in a hurry. Hopefully. Well, I mean, I'm in a hurry. I kind of feel like, you know, like slowly bringing this stream to a close, because it is like, you know, a good point where we've finally debugged this. Why is it slow to compile? Andrew, could you make LLVM compile faster? Because I think that LLVM started in. Okay, doesn't really make sense for it to be this slow. Or does it? Oh, yeah, right. Okay, so maybe that's because there is like a bunch of like debug printfs. So let's actually check. Well, while it's compiling, let's check if we don't have any debug prints left here. Okay, so it is, in fact, quite a bit slower. Okay, I hate programming. I mean, I don't hate programming, but yeah. Why are you slower? Why are you doing this to me? I kind of like really hope that it wouldn't make any difference with performance. Okay, yeah, sorry. So let's maybe cut it here, because folks, I feel like I need to go through like, you know, all the stages of grief after like this long refactoring, which resulted in slower code. Unbelievable. But well, okay. I mean, like it's normal. It's programming. You can't like win every day, or at least like, you know, you can't win at least once in a series of 5 episodes. And well, see you next week. Maybe we'll figure out this performance puzzle. Goodbye.